Welcome to AI for Good, the leading action-oriented global and inclusive United Nations platform on AI. Organized by ITU in partnership with 40 UN sister organizations and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end, as we will hold a 30-minute networking session in the neural network. Here you can meet, ask questions to our distinguished speakers, connect, and chat with the AI for Good community. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Thank you, Anna. Welcome, everyone. Good morning, good afternoon, good evening from me as well. I'm Guilherme Martinez-Roura from the International Telecommunication Union, and I would like to welcome you all for joining today's AI for Good webinar on AI-powered vehicles for humanitarian aid deployment, jointly organized by the ITU and the World Food Programme with the participation of the United Nations Office for the Coordination of Humanitarian Affairs. This session is part of the AI for Good programming track, where we discuss the role of AI-powered robots in achieving the United Nations Sustainable Development Goals. We have a distinguished set of panelists today, but as always, we are counting on you, the participants, to help create a very interactive session. Without further ado, I would like to introduce our great moderator today. His name is Kyriakos Kouparis, and he's the head of Frontier Innovations for the World Food Programme Innovation Accelerator in Munich. Kyriakos, welcome, and the show is all yours.
Thank you, Guillaume. Thank you so much for collaborating in this effort. It's been really great working with ITU to put together this great panel and this session on AI-powered vehicles for humanitarian assistance. I'm really excited to see the many folks who have joined us, and therefore I would like to first introduce Annalisa Conti, the director of the WFP Geneva office, to help kick off this session. Annalisa, over to you.
Thank you, Kyriakos. So as many of you know, actually probably all of you know, WFP is mandated to provide food assistance to the hungry and most food insecure people. Over the past few years, WFP has resorted to use artificial intelligence and robots to more efficiently assist people in need of food. One of our key tools is the Hunger Map Live, an integrated global hunger monitoring system to predict the magnitude and severity of hunger at any given time across more than 90 countries, providing governments, but also the broader humanitarian and development communities, evidence-based information to more effectively address hunger in all its forms. Information collected daily by call centers around the world, along with historical data on food security and its underlying causes, are combined with artificial intelligence in the form of machine learning-based predictive models in order to predict food security in real time. Artificial intelligence has unlocked the opportunity to monitor food security in countries where data or infrastructure and resources to collect data is limited. As a result, WFP's Hunger Map Live has been predicting the food security situation in close to 60 countries, meaning that daily data on the food security is now available in these countries to anyone, anywhere, at any time. However, the environment where we work is often extremely challenging. In those circumstances, we have been resorting to the use of robots and drones to do our job. For example, in the aftermath of Cyclone Idai in March 2019, WFP used drones to enable the government of Mozambique to carry out a rapid disaster mapping. Local authorities had been trained by WFP on 10 different drone systems. And in just 2 or 3 days, over 70,000 high-resolution images were captured to inform the relief operations. This was nearly half the time that would have been required to conduct a manual damage assessment. Building on the need to respond faster and more efficiently to climate shocks, WFP developed a machine learning application called Digital Engine for Emergency Photo Analysis, or also called DEEP. This application reduces the time it takes to identify damaged buildings and structures from a high-resolution drone and satellite images, making it effective to deep field operations while lowering operation costs. The DEEP application has been used in the aftermath of Hurricane Iota in Colombia, Typhoon Goni in the Philippines, and to assess the damages after the blast in the port of Beirut, Lebanon. It has shortened the assessment process from weeks to few hours, with an 85% accuracy in detecting damage. So as you see, artificial intelligence and the drones are facilitating WFP's assessment efforts, allowing us to respond faster, but de facto helping us to save more lives. Thank you, and over to you.
Thank you, Annalisa, for sharing many practical examples how AI is used in the field to help deliver impact where it really matters. I will now pass it over to Andre Veretti, the team lead of digital services at the Information Management Branch at the UN's Office for Coordination of Humanitarian Affairs. Andre will be sharing with us some considerations and frameworks that we should take into account while deploying these technologies to ensure that they are used for maximum impact while minimizing the risks involved. Andre, over to you.
All right, thank you very much, Kyriakos. I felt like a long introduction, a long title there that I apparently must have shared at some point with you. Appreciate that. Yeah, so I'm coming at this from our organization of OCHA. Our business is around coordinating humanitarian affairs, where we are often maybe a step back from those, delivering the aid, delivering the food type activities. But it means we have a little bit more, sometimes a higher view. We're in country trying to assist with coordination efforts, but also things like funding, advocacy, but also the policy side of issues. And that's where I'm sort of, your comments about where I'm coming from today speaks, I think, mostly is, the sort of the policy, ethical side of things. And for those who maybe haven't seen it, I would encourage you, OCHA recently put out a policy paper written by the policy team, and I'll read this so I get the title correct. But From Digital Promise to Frontline Practice, New and Emerging Technologies in Humanitarian Action. Now, this is a 50-page paper, and there are pieces of it around robotics. It focuses more on the aerial side, but there's a lot of very legitimate pieces in there, I think, for people who are interested to engage in the space and maybe haven't in the past to take a read. So where I come at it from is looking at the sort of overall considerations, the policy, the ethical, the coordination side of introducing, let's say, robots into humanitarian space. How do we make sure that we are, doing that in the most constructive way possible? Are there legal frameworks in a given country. I know as of a couple of years ago, when we did a bit of a sort of analysis, there was a lot of countries still lacking, clear regulations around UAVs. But whereas on the other side, you might take Europe, and I understand that, a few years ago there was the Drones Amsterdam Declaration trying to make things more consistent, at least in my opinion, for the operators to understand, what they need to do in order to fly drones in countries or potentially other robotics. So that's where we're looking at it, and where the reason that I come and stress that point is my interest is making sure that these really amazing innovations and approaches that I think, while we already heard a bit about from WFP, we're going to hear from several panelists. How do we make sure those are successful, right? And sometimes it's a very little annoying policy or legal things that catches up somebody. I've seen all kinds of organizations engage and do amazing things. And I remember in Nepal, one little case where an organization forgot to register with the right authorities, so it caused headaches for themselves and for the authorities and for myself at OCHA. How do we avoid that? So we're doing as much as we can, and as constructively as we can. And it's easy to jump into this, right? I remember one of the quotes. I think one of our panelists talked about it, that technology is like 10% of the solution. Right, so just because you can fly a drone or run a robot, it doesn't mean you've figured out how to do that in a different country, different social norms, different laws, regulations, and that you're doing it in a safe way. And when I talk about safe, I'm also thinking now, as we are using more and more technology, more and more AI, how are we treating the data that we might be collecting through these mechanisms, especially in insecure environments, right? Like, these might be really amazing data to help us make faster decisions, right? We've already heard that from WFP, but how are we managing and handling that data, right? In conflict zones, whether it's Yemen, Ukraine, or these kinds of situations, this data could be sensitive. Flying medical drones, for example, in certain areas, could that be leveraged by, a nefarious actor that is wanting to cause problems? So how do we protect the local population? How do we protect that data so that we aren't causing harm, but are reducing the risk of causing harm, and that we're maximizing the potential impact of that? So that's where I come from. I think OCHA, we see lots of potential here, both for the robotics side, but also AI outside of robotics. But it's all, in my opinion, around the responsible use of those, and sitting actually here in the Center for Humanitarian Data, the responsible use of the data that is either leveraged by these robotics or is generated by these activities. So I'm looking forward to hearing a little bit about that aspect of it from the panel members. And I think, sometimes as boring and as dry as these topics might be for those people who are really in there getting things done, unfortunately, they are, an important aspect. And I think if we address them correctly, we can do a lot more and do it better. It's back to you.
Thank you, Andre, for those excellent words and for highlighting the need that we have to, first and foremost, always adhere to the do no harm principle that guides all the work that we do as humanitarian organizations. And you're very right. These technologies have immense potential, but they have to be explored cautiously and done in the appropriate manner. We will now turn to our four speakers, who will each give us an example of how they have used AI-powered vehicles or unmanned aerial vehicles in the context of humanitarian assistance and support. First up, we have Armin Wedler from the German Space Agency, who will talk about a collaboration with the World Crew Program in developing a remote-operated amphibious vehicle. Armin, over to you.
Yes, thank you, Kyriakos, for having me and inviting me. And thank you also to my previous talker, to Anna and Andre. And I'm fully aware of what you're saying, and I can back it up, Andre. So that's a big aspect, especially if we talk about AI. So let me start with a short presentation of, let's say, the project. We are very happy here in DLR. We have, together with Kyriakos, we managed to acquire this cooperation project where yeah, my title for today is AI-powered vehicles for humanitarian help and the vision behind the AHEAD project. And I try to give you a short insight. And I'm focused on the technical aspects. So my previous talker has mentioned maybe in the panel, then later we can talk about it. So let me explain a bit or start from where we come from. I'm from the German Aerospace Agency, and my team and I, together with some other aspects, we are working mainly on automatization or teleoperation of planetary exploration vehicles. For example, we are envisioning a cooperative scenario, as you can see from NASA GPL currently applied to the Martian rover Perseverance with Insurity, with a drone Insurity, which is exploring in a manner of partly autonomous functionality the Martian surface, so scientific questions to be answered for human society. So that's, let's say, the main track my team is working on. Thus, we are working with vehicles which are difficult to operate, with weak communication aspects and interruptions in communication and very low data rate. And at this moment, we got in contact with the World Food Programme on the incubator here in Munich. We saw that it's a good idea to transport technologies and methods we have developed here at DLR, mainly for the space application, towards humanitarian help and aid. And that we managed to establish within DLR the so-called AHEAD project, Autonomous Humanitarian Emergency Aid Devices. And we have the idea, and we figure, we are currently also in the process of figuring out how cooperative remote controlled vehicles and teleoperated vehicles could benefit in certain areas the needs of the World Food Programme and delivery. We are mainly focusing with our wheeled vehicles, with our say ground-based vehicles, on teleoperated drones for transporting goods, especially in danger zones where the humanitarian drivers are in danger. So we would like to enlarge the reachability of food delivery. And we have envisioned, or we have defined also in our project, that only the last mile of the delivery is a challenge for it. So the project is complex, and I will just roughly go over it. So we are combining satellite data to plan a very rough path. We are deploying a local mission operation center, such as a container vehicle, which we also use for space exploration testing missions. And from there, we build our own communication chain towards a chain of cars or even one car. And we have a little landing pad of a drone on the top of the vehicle to get a bird eye view on the vehicle. So why we're doing this, I just roughly touch this topic. So we want to protect drivers who are exposed to danger during this humanitarian delivery process. We're only focusing on the last mile. We want to expand the possible deployment areas which currently can be reached, and we'll have economical reasons or ecological reasons. Especially economical reasons are we are competing with such vehicles with airdrops. I think for very challenging to reach areas, airdrops are cost intensive for World Food Programme. Yeah, let me talk a bit of AI. So what is the complexity in our robotics? So usually we are starting from sensors, which gives us input, and we want to steer and operate something. And between those, between those action chains, which needs to be done on the vehicle itself, so it needs to be done in a certain automatization manner. We have perception, we have navigation, search and exploration, and we have complex algorithms which work together, which could be considered partly as AI, but I would say also model-based algorithms are very important for us. So we want to plan within this knowledge and reasoning chain on the system itself, and finally perform a mission which is controlled by an operator or supervised by an operator. And all this will be done in a process monitoring via a central operation system and this local operation system, which I just showed you. In this cooperation project, we got the shared car of the World Food Programme. So that was meant, or that was brought to us by the World Food Programme. So finally, we got the information that this car is already deployed in several areas. It's very interesting, and it's very like for us to use such a car, because we see a lot of a planetary exploration vehicle in it. It's capable of swimming and it's capable of driving in very harsh environment. We are applying our technologies mainly of robot vision, and now it comes a bit to the approach of AI. So we are challenging the task of 3D localization, mapping, navigation, and exploration. We want to, let's say, detect objects in this area. So for example, we need to detect persons, which are just tracking, which is not happening in space applications. So we are here now challenged with this new approach that there are objects to be detected and to be analyzed. And the classification of those objects is often done by using learning algorithm, AI algorithm. I just put this, let's say, a bit high level sheet here inside, which shows a bit that we are, by automatization, we are very much, in robotics in general, I think, is currently in a phase of, we have a lot of neural networks and possible capabilities of learning things, but we are also always competing with the model approach. So the model approach or the learning approach is easy. Deep architectures can be used broadly, and software frameworks are currently available. They're effective because many standard perception tasks can be solved by deep learning, but it requires large amount of training data. So the neural networks only get better and better when a lot of training data is available. And that's for space a challenge, but also for humanitarian help, because we might not have all those things. And also my previous talk, I just can back him up, as Andre said, those data might be critical in terms of, let's say, privacy and some other reasons. So the model approach is what we're doing since several years, several decades of years. It's precise. We do physical and geometrical models, which are very accurate, and they are precise to be operated if calibration is good. Physical models are small with a few parameters, and you can, let's say, calculate and perform them very, very fast. It doesn't scale to large problems. So if we have a very complex situation and we need to analyze them, so we are probably very difficult. We are in difficulty to model those approaches. So the approach we are following in robotics and DLR here, and I will only speak for us, is that we try to combine those both models, methods of using neural networks for solving specific tasks, for example, semantic classification, and to apply them in model-based control approaches. So we have set up already the car with several perception methods, such as stereo cameras, but also LiDAR scans. We have a simulator, which is talking about AI. We need to generate data, and if we want to generate data, which is, for example, considering all privacy aspects, as mentioned before, it might be good to use and have simulators. So we have one space simulator, so for example, which is capable of us, it's shown here in the picture down, to really generate camera images out of a virtual environment. And you can see that in the second view perspective. So every camera we have mounted and shared for now is now able to be visualized. Unfortunately here, Sherp is driving around Mars, which will not be the case. So we can, the next scenario will be South Sudan, but we need to get data out of that. And this makes us possible of feeding this data towards our neural networks and make them better. And let's say that's what we mainly call AI. A lot of that's AI and all this use of these words is very widespread and very common in the moment. So I'm very careful with saying what is AI and what is real artificial intelligence, because a lot of model-based approaches are wrongly named as AI, to my understanding at least. So I want to clearly state.
I hate to interrupt you. This is a fascinating talk. In the interest of time, however, we will have to wrap up in a minute or so. Thank you so much.
I'm over the time already, and my time is not. I have still 30 seconds. No, Okay, sorry for being over. I have a clock running here, but this is a teleoperation we are envisioning for now. So this is with a safety driver. So we really have the physical approach here. I just want to say that the project is not that big that we can do and solve every problems. For example, also the ethic problems and the safety problems just mentioned, privacy. But we are touching them, and we don't want to overcreate expectations. But my aim is to really deploy a car in South Sudan at a later stage. And well, that's it. So rough overview. Thank you, Kyriakos, and sorry for being over. I was
only by a few seconds,
Thanks.
Aaron. This is excellent. Thank you so much. That was a great overview of what seems to be a very exciting effort. Now we're going to turn our attention to drones and the use of drones in the delivery of health supplies. I will now pass it on to Mickey Sofer, Senior Vice President of Global Health Partnerships at Zipline. Mickey, over to you.
Great. Thank you, Kyriakos. It's a real pleasure to be here today. I'm excited to talk about how Zipline is automating supply chains and some of the applications of drones that maybe this audience hasn't considered yet. So Zipline started as a robotics company, and we began applying our technology to global health back in 2016. We operate the world's largest automated on-delivery network. Our mission is to transform health access. When we first started, we noticed that health systems were built on these kind of slow-moving, archaic, and costly push-based supply chains, and they operate by overstocking products all over a country and then require many months of planning out in advance because it's too complex and expensive to respond in real time. They also tend to be very fragmented, many different actors touching the products in the supply chain, which makes it difficult to assure any quality control. The result here is that products may or may not be available for patients who seek treatment, which then leads to poor health outcomes. Zipline saw the opportunity to begin moving the needle here by automating a pull-based supply chain. This means stock is centralized and we can guarantee universal product access 100% of the time to any point in the country. We can assure quality control without incremental cold chain investments. And the system runs on complete, accurate, and timely data. So you always have a picture of where our products are going. So everyone knows Zipline for our drones, but we're actually an integrated end-to-end supply chain solution. We operate out of warehouses, each of which centralize commodities for all health facilities in a 23,000 square kilometer surrounding area. We create these networks of these warehouses so we can cover every point of care in a country on demand. And from these warehouses, we do last mile distribution. The way that we manage inventory is designed to eliminate waste from the supply chain by distributing first to expire products, and also by eliminating most of the variables that can affect product integrity. You'll notice that Zipline's drone is a fixed wing drone. We get many questions about this. We knew that our solution had to be able to fly in all weather conditions, travel long distances efficiently, and securely and safely transport sensitive medical goods. And most of all, to service a use that's so critical and that lives rely on, we had to optimize for speed, scale, and reliability. So the fixed wing format satisfied these requirements in a way that other configurations did not. So I'm going to share with you a time-lapse video from our distribution center in Bobsi, which is in northern Ghana. So this first image is of our fulfillment center, which is one of many supplying every point of care in a country on demand. This now is our flight area where trained operators prepare the Zipline drones for launch and retrieve them upon return. Then the image on the left here is our flight map. Each of the triangles is an aircraft that's out for delivery, flying completely autonomously along predetermined routes. And then to give you just a little bit more detail beyond that on how it all works, we try to make the system very easy to use from the health provider's perspective. There's no software integration, hardware, data entry, or auditing of stocks required with Zipline. Simply, anytime a health worker needs a test or a treatment that they don't have in stock, they place an order via phone call, text, or WhatsApp. So it's really, really easy. Our fulfillment operator packs the order and hands it off to a flight operator, and then that person places it inside a Zipline drone and launches it for immediate delivery. The drone then flies to the GPS coordinates that are associated with that ordering facility, drops the package into a specified catchment zone, and it's picked up by the health worker who's been notified that it's arrived, usually by WhatsApp. The drone doesn't land at the delivery site, making this a very highly repeatable and reliable operation, which I think is, really key, a key topic of the webinar today. Instead, the drone returns to our hub and it's recovered by a cable that catches the aircraft's tail. Then from each hub, as you can see, we can do dozens of these flights simultaneously in order to fulfill hundreds of orders per day. And all of this can be completed in under an hour from order to delivery. And just to give you a sense of that scale, right now we're making a delivery about every 3 minutes in Africa. So this keeps going and going until about 7 p.m. in the evening. You get the idea. So the third part of Zipline's system, also really important, is our data platform. It tracks every unit of inventory from the warehouse to the point of delivery, giving clients visibility into consumption across the whole system. We can account for every product, meaning theft and counterfeits are essentially non-existent. No data is ever self-reported, meaning there's no opportunity for human error and much greater data security. Again, a really important focus of today's discussion. Based on this data, clients can adjust their forecasts, right-size inventory, anticipate challenges, and make better decisions about how to allocate resources. And like I said, data transparency and accuracy, it's really critical challenge that governments and development partners are trying to solve for, and Zipline makes it easy for partners to see how their supply chain is performing and take action as needed. So what we're looking at here is our current and planned footprint in Africa. Since Zipline began operating in 2016, we've made more than—
Sorry to interrupt you. I'm being notified by the audience that your slides are not coming through. I don't know if you can try resharing really quick.
Oh, shoot. Hold on. Let me go back. Did I not share my screen? Shoot. Hold on.
No, you didn't.
Oh, my goodness.
No worries. It happened.
It'd been nice to know that like 5 slides ago. All right. Geez. Opa. Okay, you see them now?
Yes, now we see them. Thank you for that.
Oh gosh, so would you like me to go back at all?
No, I think in the interest of time, just
okay.
And we'll share the content afterwards.
Okay, I apologize. The time lapse was like really exciting, so that's a shame.
It happened.
Okay. Yeah. All right. Anyways, I'll continue. So like I said, we've been operating since 2016, and we've made more than 280,000 commercial deliveries and flown more than 20 million autonomous miles. We operate 2 distribution centers in Rwanda and 6 in Ghana, serving over 2,500 health facilities that care for 36 million people. And then in the next 6 months, we're going to be launching operations in 3 Nigerian states, Western Kenya and Cote d'Ivoire, expanding our coverage to more than 45 million people in Africa this year. And our involvement is always government-led, so we enter and build these really efficient systems at the government's behest at the national, state, and county level. And our teams are also 100% local talent. So we have more than 400 employees across Africa now, and we're adding up to 40 new skilled jobs per distribution hub. So that's what Zipline does as a high level, but I wanted to give a few specific examples of our work. Our next launch is Nigeria, which offers a number of humanitarian angles where on-demand delivery adds a lot of value. The whole part of northern Nigeria has insecure roads, which make shipping medical supplies to this part of the country very unreliable. There's lots of armed banditry, and ground deliveries are usually accompanied by military convoys, which are a steep expense. In Kaduna State in northern Nigeria, Zipline's implementation is going to help guarantee the arrival of medical supplies and secure the safety of healthcare workers and those supporting deliveries whose lives are often put at risk by this work. We'll also be able to help the health system and supporting humanitarian partners reliably reach the sizable population of 0-dose children. Those are children who have never received a single vaccine dose in their lives. And so we're looking to scale this intervention to other areas that are affected by instability and violence. Then to give one additional example, Zipline was already in Ghana when the COVID-19 pandemic began. So we were able to see how the country benefited from having aerial logistics already embedded in its supply chain. One of the first things we noticed during the lockdown was a huge surge in orders for routine vaccines. And this was because most facilities in Ghana store their vaccines offsite, and lockdowns were restricting health workers' movements to reach them. And as a result, by the end of the year, Zipline was delivering 10 times the number of vaccines per month as we had at the start of 2020. The response helped to limit disruptions to routine childhood vaccination schedules, which was actually one of the biggest challenges during the Ebola crisis, even more so than Ebola itself. But it also demonstrated a better way to distribute vaccines and maintain cold chain and quality. Over the last 2.5 years, we've distributed more than 5 million doses of routine vaccinations, and more than half of that occurred just in the last year, meaning 2021, not 2022. Other ways that Zipline supported the pandemic response included delivery of COVID-19 lab samples to main cities and distributing PPE for the government. So this is an overview of Zipline's work on vaccine supply chains. For the last year, we've been partnering with the government of Ghana to distribute COVID-19 vaccines, and we actually just passed the 1 million doses delivered mark. The way this model works is the government administers vaccines in urban areas and then centralizes vaccines for rural patients with Zipline to distribute all across the country. When supply comes into Zipline, it's all distributed within days in just the right number of doses needed for the next 5-hour window. This novel model has allowed the government to send the majority of doses to cities where they're having the largest outbreaks, but then also send very targeted numbers of doses all over the country through Zipline to dosing sites to make sure that they are vaccinating healthcare workers in a very cost-effective and efficient way. A study backed by the Bill and Melinda Gates Foundation recently came out and found that Zipline shortened vaccine stockout duration in Ghana by 60%. And this translated to a 42% reduction in missed vaccination opportunities, which could lead to really significant health impacts down the road. We've also looked at the impact on DALIs and found that using Zipline to fully immunize a child, the cost of a DALI averted is less than $1, which is impressively low for those of you who track DALIs. So this underscores both the impact and cost effectiveness of using on-demand delivery for targeted vaccine campaigns. So my last slide, we're now less than 8 years away from the timeline we set to achieve the Sustainable Development Goals. I think we can all agree that we need to see bigger step changes to really move the needle on SDG 3. Like we need new approaches that bring care closer to the patient and into their communities, that empowers healthcare workers to order the supplies they need, and approaches that assure that the right products are reaching the right place at the right time and in the right condition. So from enabling health access to crisis response, Zipline believes that supply chain automation is not only inevitable, but a way to ensure that we get to that future state. Thanks.
Thank you so much, Mickey. That was a fascinating journey from the beginnings of Zipline to how you're scaling quite impressively across sub-Saharan Africa. Thank you so much for sharing that with us. I will continue on the drone journey and pass it over to Patrick Meyer, the Executive Director and Co-founder of WeRobotics. Patrick, over to you.
Thank you very much, Kyriakos. Can you all see my slides?
Yes, we can see your slides. Thank you.
Perfect. Thank you. Thanks so much for the invitation, and good morning, good afternoon, good evening to you all. It's a great pleasure to be able to contribute and participate. So here is where we're at in the AI and robotics space. We're about to experience the same kind of leap forward that we went through when we jumped from the last feature phone to the first iPhone. And you can see glimpses of that, right, from the previous presentations. And so, in fact, we are really just starting to make that jump now to that next generation of AI and robotics. So it's an exciting time. And take this quote, for example. We are on the very edge of exponential growth in the drone industry, and it has a potential to transform our lives for the better. And that has got to be a goal worth working towards. And I completely agree and share the sentiment of this statement. At the same time, I think we do need to unpack a few things. Who is on the edge of exponential growth? Who gets to lead this transformation, and then whose lives will actually be transformed for the better? Who also gets to be the expert and make a career out of this transformation? And of course, also who actually gets access to the exponential technology in the first place? Well, the fact is, 99% of our conversations don't focus on those questions. 99% of our conversations in the technology for good space and in the humanitarian technology space are technical discussions about the technologies themselves and how to optimize them, their performance, and so on. We barely spend any time asking who. Now, there are several reasons for this. One of them is the fact that if you start asking who, you inevitably get to questions about power, equity, or inequity for that matter, exclusion, discrimination, racism, and more. So when it comes to our technological progress in AI and robotics, yes, these are extremely exciting times. That being said, when it comes to our progress in equity, localization, and shifting the power, we're in the Stone Age of social justice in the technology for good space. Really, we really are in the Stone Age of social justice in the tech for good space. Let's take, exhibit A of what foreign-led, top-down, and technocentric approaches look like. An international organization deploys foreign drone pilots, and what we see here is that the local community is relegated to the role of passive observers, holding the umbrella to ensure that the foreigner does not get wet. Now, this approach to social good excludes local leadership, knowledge, expertise, ownership and local ways of being. And so it's not that hard to understand why many are calling for the decolonization of aid. Don't get me wrong, it's not an either or. I don't want to paint such a simplified picture. I'm not anti-foreigner or anti-organization. Both are absolutely vital. I am simply pro-local because the exclusion of local experts is simply not compatible with social good. And of course, this shouldn't even need to be said, but here we are, because 99% of our discussions on emerging technologies ignore the agency, priorities, and expertise of local experts. Now, as foreigners, we don't have as much local knowledge or expertise when we're overseas. And unfortunately, as a result, we decide to default to technical solutions to overcome our handicap. And in the process, we tend to ignore local know-how, common sense, and local ways of being. How is this social good? Now, let me illustrate further by drawing on James Scott's seminal book, Seeing Like a State. If your life depends on your ship coming through the other end of a terrible storm, surely you would prefer a successful captain with long experience at the helm, rather than, say, a brilliant physicist who has analyzed the natural laws of winds and waves and whatnot, but who has never actually sailed a ship. Now, let me take this one step further. You would undoubtedly prefer a successful local captain with lived experience in these local waters, compared to, say, a brilliant but foreign captain who has never set sail in these specific waters. Now, again, please, it's not an either or, foreign versus local. So let me get to the heart of this matter. When a large freighter approaches a major port, the captain will almost always hand over the controls of her vessel to a local pilot, who then brings it into the harbor to dock. Now, this very sensible procedure is designed to avoid accidents. And this reflects the fact that navigation on the open seas is the more general skill, while piloting a ship through traffic in a particular port is a highly localized skill. What the local pilot knows are the local tides and currents along the coast and estuaries, the unique features of local wind and wave patterns, shifting sandbars, unmarked reefs, seasonal changes in microcurrents, and so much more. So local knowledge is particular, and it can be acquired only through local practice and experience, which means that the local pilot's experience is locally superior to that of the foreign pilot. And now the trouble in the social good space is that the majority of captains and their ships do not turn control over to local experts. And it's equally problematic that most captains and ships are white, male, Western, international organizations, and startups, of course. Now, how are we in our own small way trying to approach locally led practice in the AI and robotics for good space? Well, for the past 6 years, we've had the opportunity of working very closely with hundreds of proximate leaders, dozens of local organizations in 30+ countries to co-create FlyingLabs. FlyingLabs are independent and locally led knowledge hubs that combine local expertise and leadership with emerging technologies to drive positive social change. And all these FlyingLabs are directly connected to each other, sharing best practices, lessons learned, other types of insights and opportunities. And of course, FlyingLabs are not just dots on a map. There are very real people here with a wide range of domain expertise and lived experience across so many different kinds of sectors. And our role within the FlyingLabs network as WeRobotics is to serve as an enabler, to facilitate knowledge exchange, technology transfer, and to drive meaningful opportunities to FlyingLabs and their local partners. And together, they're engaged in multiple sectors, as you can see here. And they decide which sectors to engage in. FlyingLabs decide what partners to team up with, which projects to pursue, how to put together their teams, and so on. They truly are independent and local. And I should also note that FlyingLabs are actually hosted by locally owned and locally managed organizations. And so over the years, FlyingLabs have been involved in a wide range of projects, from disaster response in Nepal, climate adaptation in Panama, and critical cargo drone logistics in Madagascar, as well as other FlyingLabs around the world. And I want to end by just sharing a bit more about our approach with FlyingLabs with respect to medical drone delivery. Now, this is not a better approach. It's, again, not an either or. It's a both and. It's complementary, right? Here's how we go about doing drone delivery. We're all about local ownership and autonomy. We're fully technology agnostics. And I won't read everything else here, but just to end with saying, we actively support local cargo drone startups. We help also incubate locally owned drone startups that then offer drones as a service. Now, this approach is not random. It's directly informed by the localization model that we've co-created with FlyingLabs over the past half decade. And amongst the key features of this model are our strong commitment to local autonomy and South-to-South collaboration. WeRobotics is actively ceding market share to FlyingLabs and their partners. We are devolving money, power, and voice. As many of you will know, in the humanitarian space, barely 5% of funding from international organizations, humanitarian organizations, go to local organizations. Well, last year, thanks to this model, WeRobotics transferred 45% of our funding and resources to FlyingLabs, local organizations, and their partners. So it is possible. And to learn more about this model, it's not magic. We've just produced this report, this write-up, co-authored by multiple FlyingLabs.
Sorry to interrupt you. Unfortunately, we will have to move on very shortly. Can I ask you to please wrap up?
I have just 10 seconds left. And so if you want to look into how to adopt and adapt different features of this model, this is the place to go. Because amongst other things, by adopting these kinds of features of inclusion and so on within the humanitarian space, this will allow you to move out of the Stone Age of social justice into a much better place where we should be as far as inclusion, equity, and equal opportunity go. So I'll just end by saying, hire smart, hire local. Thank you very much.
Thank you so much, Patrick, and thank you for emphasizing the human element and the person dimension of what we do. I think you brought up a lot of good points about embracing and supporting and elevating local knowledge and ownership. And with that, I want to pass it over to Heidi Sampan, who is the managing director of the Philippines FlyingLabs, who will talk about how this has happened in practice in the Philippines. Heidi, over to you.
Thank you so much. Okay. Can you see my screen?
Yes, we can see your screen.
Yes. Okay, thank you so much. Thank you for having me here. I'm coming from the Philippines, and good evening to everyone. So, as Patrick said, we're part of the FlyingLabs network, and I'm here to share our field work. We just recently concluded our 3-week field work delivering medicine using cargoes. So Philippines Flying Labs, as Patrick has mentioned, is locally led and it's locally managed and focuses on local expertise. So in terms of Philippines Flying Labs, it composed of 2 organizations, SRDP Consulting, which specializes in GIS mapping and survey. So all our drone pilots are from this company, and they have extensive flight hours of flying drones. And as a matter of fact, SRDP got its first drone license from Civil Aviation Authority of the Philippines way back in 2015. So that's our tech expert. In terms of health expert, it's remote area medical, which I lead as well, where you provide free medical care in remote areas. So I have the health know-how. I know where the health inequities are, and I have good relationships with people at the grassroots level. So it's a good synergy between the 2 organizations. So as a background, I just want to show you the Philippine health system and why are we encouraging the use of AI-powered vehicles in this scenario. So as you can see, Philippines is mainly composed of 7,400 islands. We're really surrounded by water all over. We have an extensive coastline of 37 kilometers. And aside from that, we're also along the Pacific Ring of Fire. And so we're very prone to disaster. And I'm sure all of you have been to the Philippines during the Super Typhoon Haiyan in 2013, just because we were caught by a huge super typhoon. And the most common problems in the Philippines is actually inequity in health status and access to services, especially in those remote areas. Asia is developing, we are developing, but our national capital region is developing. But when you go to the outskirts, to the remote areas, we still have ways to catch up in terms of health outcomes and health indices. So this is one example of our field work last few weeks ago, geographically isolated disadvantaged village. We have a lot of these in the Philippines. In this particular area, it's called Sipangkot, and as you can see the red mark, it's way back at the southernmost tip of the Philippines, almost close to Malaysia. So there's inequity because of the geographical isolation. And just to compare, facility-based delivery in this area is only 12%. They still have home births, and unfortunately, complications can come from that, both in the maternal and infant health. And then childhood vaccination coverage is only 29% compared to the lowest quartile in the country, which is 59%. So they're really not adequately vaccinated. And in terms of COVID vaccine, 26% are fully vaccinated against COVID versus 70% in the National Capital Region. They're saying it's not because we have inadequate quantity of vaccines, it's just the health people cannot reach those people in those remote areas. That's why they're not fully vaccinated in this community. And as you can see, they only use a small boat to move around. The other community that we targeted during this time is the indigenous people village, the tribes. And usually indigenous people are geographically isolated. They tend to be socially excluded. And in this case, we went to Binakalan, Agusan del Sur. As you can see, the topography is more mountainous area. And this is the picture in the middle is called the Habal or Skylab. It's a makeshift motorcycle where they have wooden platforms on the side where they balance the cargo and the people. So you have to traverse the 11 kilometers from our site, it took us 2 hours because of the muddy road conditions. And only 2 things can happen here. The motorcycle will fall down, causing injury, or you have to walk just because the motorcycle cannot handle certain weight at certain point in time. So as mentioned earlier, PFL setup is locally owned and operated. We have our drone platform. We're using a DJI M300 of common off-the-shelf drone, but the cargo box and the software has been customized by WeRobotics, and 2 engineers from WeRobotics share their knowledge with us, and they train our pilots for 1 week, and transfer of knowledge. So now we have local experts operating our drone, and we're proud to say that we're the first to obtain the BV loss authorization in the Philippines. In this purpose, we're doing it for drone deliveries, and our mobile drone ports are very nimble. We can set up easily from end to end, as long as we have good GPS locations of the site and we have good connectivity. Then we can set up different mobile ports in one municipality, for example. And also, I have to emphasize the importance of cooperation between multiple stakeholders and partners, because without this cooperation, you cannot really have a sustainable program. You cannot have a buy-in from the community if you really don't work together with other organizations. So in this case, we have the drone delivery from the CAAP. We have the funders, of course. We have the government. We have good relationship at the Department of Health at the provincial and the local level. And also, we have partners from the military who are doing humanitarian assistance and disaster relief operations. And of course, we also have civil society organizations helping us. So it's a multi-sectoral partnership to really improve the health of the community. So this is our recent delivery, where I'm so proud to say that we had our first inter-island delivery in the Philippines. Usually it took 30 minutes by small boat or longer if there's low tide. But in this case, we were able to do it in 8 minutes. This is an actual drone footage. As you can see,
I'm impressed right now that we're getting such good.
But yeah, so it's the drone actually, flew smoothly over the ocean and delivering the essential medicine, because apparently in Sipangkot, they have stock out of this medicine for several weeks, and they were happy that they were able to get the oral rehydration solution from us, just because they're having huge cases of diarrhea. So that's the beauty of this delivery system. It's rapid and accurate. So the other delivery that we did was Janssen vaccine, COVID-19 vaccine. Our cargo box has been retrofitted to be able to handle the finicky ultra cold chain storage requirements of these vaccines. And this video is the first time that we were able to deliver the Janssen vaccine. And this is the local health officer in charge of cold chain storage. He was the one who opened the vaccine for us.
Yes, okay. Yeah, all you have to push. Just push it. Yes. Okay, then we get this out. Doctor, you can give.
So we have a temperature monitor all throughout the flight, and they were able to maintain the 4 degrees Celsius all throughout, which is nice, and we were able to transfer to the locals cold chain storage. And the beauty of this one is, like, within 5 minutes of delivery, we were able to use the vaccine delivered via drone. And so that might simplify the logistics planning for the future.
Yes, okay.
So this one is a different scenario. I'll show you. It's the mountainous region. As you can see, this is very dramatic. You can see from the clouds, and then once it starts clearing out, you'll see the mountains and the trees. With this one, we were, this is the habal for 2 hours. With the drone, we were able to do it in 9 minutes, quickly, very efficient. And what's the nice thing about this one is we did 2-way deliveries. We did medicines and Pfizer vaccines for 5 to 11 years old. And then on the return flight, we were able to send water samples and TB samples. And unfortunately, the water samples came back the next day positive, all 5 samples positive for E. coli. And actually, the water sample testing was not routinely done because it takes the water samples need to be in cold storage and it needs to be tested right away. But unfortunately, with this logistics, they might need 2 days. But with the drone delivery, we were able to deliver within 30 minutes, and they were able to send it to the tertiary center for testing. And that's why they were able to check for the quality of the water right away. So yeah, so these are the benefits of using drones, and has been discussed extensively earlier by my colleagues. But also, we want to emphasize it's less energy consumption, it's better for the environment, and these are the SDGs that we have targeted during our field work. So I think this is the most critical part now that we're done with our field work, is the challenges for drone services. One is the legislative and regulatory issues, especially in the Philippines. Our drone regulations are not so robust yet, much so for BV laws. And that's why I think having that permit from CAAP will help the authorities as well to formulate a much more solid plan based on what our experience and what our operations have been doing the past 3 weeks. So it's a collaborative process between CAAP and us. And then, of course, once you start scaling up the operations, once you start making it more regular, you need more technical expertise. You need drone pilots living in the area, or coming from the area, because it's going to be on demand. So that's a good point to consider. And then, of course, the initial setup for infrastructure is kind of expensive, but you have to, but in the end, I think once you start doing regular deliveries, then the ROI will be much frequent. And then I think the most important thing that you have to consider when you're doing this new and innovative technologies, you have to get the buy-in from the end user and make sure that the public accept what you're doing. And that's why you need to have a good working relationship with the local health officials, with the local community, and ensure that you're not replacing any existing technology that they have right now. Just because sometimes they get threatened, they will say, oh, we've been operating for a while and we didn't have any issues. Why do we need drones? But you need to tell them, we're not replacing any technology. We're just enhancing and making sure that you have an alternative just in case there's bad weather, or if the hubble driver is sick or something, or injured, or the boats are not available. So you have to give them the option of and thinking more about it so they can start adapting it. And we're lucky that after this proof of concept, we are going to do a much more regular delivery in Tawi-Tawi with the agreement by the provincial health officer. So I'm meeting them next week so we can finalize the plans and the regular scheduled delivery.
Great, you're reaching me. Thank you so much.
Yeah, so I'm just to share, this is a favorite quote of my favorite global health practitioner, Paul Farmer. Unfortunately, he died recently. The idea that some lives matter less is the root of all that is wrong with the world. And that's why we're doing last mile service delivery, because we feel like everyone is valuable wherever you are, even you're in the remote areas. And that's why last mile service delivery we need to strengthen in our country. So thank you so much. And please feel free to reach out to us for any questions or concerns. Thanks.
Great. Thank you so much, Heidi. That was a great narrative about how drones are being used in the Philippines for last mile delivery. Thank you so much for sharing. And with that, this ends the panel session of the webinar. And I would like to ask the audience now to please share any questions you may have for any of the 4 panelists. Feel free to type it in the chat, and I will do my best to moderate and make sure that we get to all the questions. While we're collecting questions from all of you, I did want to kick it off with one question of my own. I'm going to go first to Armin. Armin, you presented a lot of technical detail about all the work that is happening in the lab. It looks very impressive. The simulation looks really good, albeit it is on Mars. What are some of the challenges that you anticipate once you're field testing in South Sudan?
Yes, thanks, Kyriakos, for the question. And I think you're touching the point we discussed a lot, also during the project acquisition phase, but also in the current stage. So I really emphasize that the other presenters here today that are probably much more in action already and applied to the field. So my specific goal is to make this happen and to bring it really in a use case. So that needs to be a little bit, let's say, thought from the perspective of where I am. I'm in the Aerospace Research Center in Germany, and the aim of our research center is not to produce any products. So we had this robotic spin-off companies. We have also a lot of participation of spin-off companies I've shown, which are all bringing stuff to this nice endeavor and this beautiful vehicle. So the supplier of the perception unit is a spin-off, Roboception. The supplier of the LiDAR system is a spin-off, it's Blickfeld. And the supplier of the automatization instrument is a spin-off, it's Sensor Drives. They're all partners with us, and we are aiming to develop a prototype which should be deployed in the field. And that's, we are still searching for some future investments to be done to make this happen. But I think it's a big challenge to really make it demonstrated. We have in space, we have this technology readiness levels. So we would like to achieve a technology readiness level of TL6, something like that, that makes this kind of, I would consider it very challenging approach to be demonstrated that's functional in, we focus on the South Sudan case. We envision now with actual phase, probably many other use cases, but I think it's good to have one case and to be focused. And I'm as an optimist, I'm convinced that at one moment we can do this together, Kyriakos, and I'm really looking forward for that. And then it comes to the phase that we see to, that needs to make, as all my previous, I can just support it. We want to back up local capabilities that needs to be made in a business functionality. But that's not the task we are at the moment. So we are now at technology development. We are trying to get all inputs of all potential end users. So we're doing studies of what could be other use cases. We are very careful of what is locally really needed in South Sudan. And of course, my 35-person team here is very focused on technical issues. And since the call was made as AI, I tried to bring in some AI aspects. I hope that was okay. But I'm not so practical as the others.
No,
but
that's
again,
really helpful, Armin. Thank you so much. And I think the point that you're saying about bringing in the local context, I think resonates, and is something that Patrick highlighted quite a lot in his presentation. So it really is about making the technology work where the action is really happening. So thank you for that. I'm going to turn the next question to Mickey. Mickey, you've talked a lot about the journey of Zipline, and it's quite impressive, the scale that it has reached over the last 8 years. And you also showcased a timeline on how you plan to expand beyond Rwanda. Can you talk a bit about some of the challenges in terms of scaling, but also some of the secret ingredients, if you will, that has enabled Zipline to scale so successfully? Over to you, Mickey.
Those are two different questions, but really good questions nonetheless. I'll start with the latter piece, where we've been successful. I think I had the privilege of joining the company about 1.5 years ago, and my background is actually not in development or health. I kind of learned it all. My background is in technological startups and kind of breaking down the barriers to commercializing technologies in new contexts. The first thing that really struck me about the Zipline team is how tenacious everyone is. And it was basically make this happen, be creative, be scrappy, figure it out kind of at all costs, because we believe so passionately about what we were trying to build. I would say the other really important ingredient, which resonates with what Patrick was saying, is the local context and the fact that more than half of our employees now are African employees. And it really is very much a locally led strategy and operation. And I think that's given us real strength. I think, coming in as an outsider, not understanding the outside context, the cultural context, how to do business there, how to overcome the regulatory hurdles. Those are things that you only get by working with people who have lived it and breathed it and been successful in that context. So I think that's really been our recipe for success there as we've scaled and continue to scale across Africa. In terms of the barriers, this is a really interesting one too. At Zipline, we're building something for the entire planet, whereas a lot of tech out there is for what we call the golden billion, and the very privileged people of the world who have a lot of excess income to spend. And the problem is the payer for so many of the services on the continent are actually from the donor world, and they decide what users are getting. There's a big interest in funding pilots, which are really important, yet there's no great way to scale innovation in the development context, even once efficacy has been proven. And Zipline thinks there should be more investment in government-led development. We've seen that the governments who've invested in Zipline, they've seen real gains, big gains in their supply chain performance and health system responsiveness. And one angle that we've been thinking about a lot is performance-based financing as a tool. We know that there's a big current of discussion amongst development partners on how to incorporate more innovation into the supply chain. But at the same time, there's a big fear of disrupting parts of the system that are performing well by transitioning to something new. So there's a desire to do it, but it's unclear how. And Zipline and other innovators have picked up on this dilemma. And pay for performance, it allows governments and development partners to basically de-risk. Since you only pay for the results that are achieved, it ensures that the best performing solutions are maintained and scaled and like more tightly integrated into the health system. So we're excited to hear that some of the big global health funders out there are discussing and increasingly encouraging these types of models. And we think they have a big role to play in ensuring that the very best technologies and solutions are given pathways to scale. So it's my very long-winded answer on that.
No, thank you so much. That I think was very illuminating, especially the fact that in this context and in many of the contexts in which we operate in the development sector, we don't get that direct feedback that you might anticipate in developed economies directly from consumers, right? If you get the dollar or the euro or whatever from consumers, then your indication that you're succeeding is that direct signal. But in many of these contexts, it is the donors, unfortunately, who dictate what gets funded and what's not. And with that, I do want to pass it over to Patrick, who talked a lot about this concept and the balance between donor-led engagement, but also really, really prioritizing local ownership, local leadership, and local capacity building. Patrick, I've heard that you're going to be participating at the upcoming Skoll World Forum, and you're going to be speaking about the power footprint. Could you tell us and the audience a bit about this idea, please?
Thanks a lot, Kyriakos. Yeah, so I think what we've learned together with FlyingLabs over the past 5+ years is that this localization model has certainly helped to expand the space for locally led practice and shifting the power. What we're also realizing is that we need to take it one step further, and this is the idea of the Power Footprint Project. Basically, recognizing that we as international organizations have an excess amount of power that we've accumulated over decades. And that, and by power here, of course, I mean authority, control, and influence. And that is not sustainable and is really undermining the whole humanitarian imperative and the social good movement and so on. And so what we're doing is we're calling on other fellow INGOs to come together to co-create metrics to measure our own power footprints, right? And of course, I'm making a deliberate analogy to the carbon footprint, right? We are able to measure the carbon footprint and have been, and that's an instrumental way to start tackling the climate emergency. But we're talking about power all the time, shifting the power, localization, but we're not actually creating benchmarks to actually start measuring that in very practical ways. This is not an academic project of the power footprint. It's far more of an activist social movement project. And so what we'll be doing at the Skoll World Forum next week is engaging with fellow INGOs and international donors to start discussing how we might co-create these metrics. And ultimately, what we would love to see is donors requiring their grantees as part of a project they're funding, that not only are you implementing the project, you're going to also reduce your power footprint as you do this project. Because unfortunately in the social good space, and I'll end with this, we tend to be very myopic in terms of what we define success as. As long as this development project meets its indicators, it's successful. But what if that project in the process has further consolidated and expanded the power footprint of Western-based international organizations at the expense of local organizations, local inclusion, local experts, locally led development? I'm sorry, but that's not success. right? But we don't measure that. So we have to redefine what we mean by success and start measuring that. And by the way, this is not just sticks. This is about actually saying there's an opportunity here, just like with the climate crisis. There's an opportunity here to be a first mover in terms of green energy, solar, and so on, right? The same thing holds true for international humanitarian organizations. This is an opportunity to get ahead of the inevitable in terms of it's written on the wall kind of thing, right? It's now time to change, and you can actually help be leading that change towards decentralization, shifting the power, and reducing your own power, because it'll make you more effective. That's the thing. It'll make you a more effective international organization.
Great. Thank you so much, Patrick. I can see you're very passionate about this, and I want to commend you for that, because I do think that local ownership is absolutely instrumental in really moving the needle in any of these issues. I want to remind the audience to keep adding your questions in the chat, and we will get to them as they come in. Heidi, next question is for you. You talked a bit about local buy-in, engaging with local stakeholders. Can you talk a bit about your journey with FlyingLabs, some of the obstacles that you encountered? Because at the end of the day, many of the panelists have mentioned that technology is only the beginning. It really is that people element that is the critical piece, whether it's local ownership or local buy-in. So can you please talk a bit about that in your experience?
Yeah, so basically, local buy-in is very important. We have spoken with different local government units. One actually deferred the offer of doing the drone program for them, just because they said they are able to reach every region. So we have to move, and we go where the needs are. And unfortunately, as I presented Tawi-Tawi, there's a definite health need there. There's a definite health indicators that they're not doing so well. So I have to, of course, in a gentle way, talk to the provincial health officer. We are offering these services just because we think we can augment what your current services. But it took a while for him to actually talk to me personally, just because I think he was kind of observing it and kind of hesitating. But after some time, we presented our work. We had good success, and we were like really empowering the local. Now he's fully on board, and he's really supportive of our program. So it's not every technology people will grab onto it. They are very hesitant. So you really have to thread it very lightly, and not all are forward thinkers. So you have to change the paradigm and the mindset.
Very, very insightful, Heidi. Thank you so much for sharing that. Another question that came in, this is for any of the drone panelists. Have you seen drones being used to deliver supplies over areas that have unexploded ordnance or minefields? Do you see a role for drones in these types of circumstances or environments? So Mickey or Patrick or Heidi, any of you, please raise your hand and let me know if you can address this question.
Should I break this down? So, oh my gosh, that's like the question to ask right now, given the Putin's war against Ukraine. Listen, as Andre Verdi will know, again, having worked with him in the past on crisis maps and conflict zones, things get extremely dicey in conflict zones. As you all know, I don't have to explain that to any of you. It's just extremely risky. But of course, then the flip side is that those technologies become even more vital because of the lack of access and the danger that people are in if they try and do kind of more traditional ground-based delivery of what have you, or but it's extremely dicey. And there's been a conversation, of course, now over the past month or so with respect to the Ukraine about possibly using these kinds of technologies. Given the experience that I had in terms of emerging technologies, humanitarian technologies in conflict zones. This is not a space that I feel comfortable myself being in, because I've seen the huge damage and the huge cost that comes with this, because we're not always going to be the world's leading experts in cybersecurity. And so it just there's lots of responsibility that comes with that. And so I'm not going to advocate for or against. I'm just going to echo what Andre kicked off with in relation to there being some very, very real risks.
Great, thank you for that very balanced view, Patrick. Much appreciated. I'm going to take one more question from the audience before we go to closing remarks. And I'm just going to ask Goyam to survey the chat to see if there are any questions that have come up in the meantime. And if not, then I have one last question for the panel. Where do you see this sector going in 10 years? So if you could imagine the future, are we going to have all deliveries drone operated or remote vehicle operated? Do you still see a future where automation is not the sole enabler of delivery and supply chain? And so I'll just open it there to see if any of you can part with the future vision, whether positive or not, with the audience. Mickey, over to you.
I don't want to be too eager to answer this one, but I did talk about how we feel it's inevitable. And, I definitely don't think everything is going to move to drones. That's just not reasonable. You're not going to replace massive truckloads of cargo. You're not going to be able to put hundreds of mosquito nets in a drone to get them where they need to go. I think it's about making it the most efficient use of the tools that we have. I think that lots of investment has been made over the last decades to achieve even before the Sustainable Development Goals were set, to make advances in health access and equity. And if you look at the charts, the amount of money is not actually moving the needle much anymore. And it's really that last 20% that's extremely hard to reach. There are these gaps that just cannot be closed, and most of them are in the last mile. And it could be more than a mile, right? It could be several miles, but the communities that are especially hard to reach, there will continue to be inequity around the world until we find a solution to cater to those parts of the population, until there aren't millions of children who are not vaccinated against diseases that have been obliterated in other parts of the world. And so we think drones have a really important role to play in kind of leapfrogging some parts of the world that just haven't had the benefits of stronger infrastructure and data technology. And I think it can be similar to what we saw with cell phones. And that's really changed the way things work in many parts of the world. And I think that many decades ago, we couldn't have imagined what cell phones would enable and unlock. And before that, we couldn't imagine what credit cards and electronic payments would unlock. So I think we don't really know what it looks like yet, but we envision a world where drones are just part of that supply chain. You have your trucks, you have your boats, you have your motorcycles when it makes sense, and you have your drones, and you decide where to use the right tool for the most efficient outcomes and for the most appropriate health outcomes.
I'll take it, Mickey. That sounds like a very informed viewpoint. In fact, integrating drones as an option among others within supply chain. And is in fact a conversation I have a lot with our supply chain colleagues at the World Food Program, which is how do we bring all these tools together to design and deliver the most effective program. And with that, we are out of time. I wanted to sincerely thank all four of our speakers for sharing their enthusiasm and their experience delivering and developing autonomous vehicles and unmanned aerial vehicles for humanitarian support. So a huge sincere thanks from me and from everyone. And I would like to pass it to Bilal Jamousi from the ITU to provide a few closing remarks. Bilal, over to you.
Thank you very much. Dear colleagues, distinguished panelists and participants, greetings to all of you. I'd like to thank you all for joining us today. Over the last 50 years, there have been a five-fold increase in the number of natural hazards and disasters as a result of extreme weather conditions. Between now and the 1970s, over 2.5 million deaths and losses amounting to $4 trillion have been attributed to these disasters. The recent volcanic eruption along the coast of Tonga in January this year impacted nearly 80% of the population in the country. Furthermore, long-lasting conflicts have also threatened the social fabric in different regions and exposed millions of people to violence and displacement. These unfortunate events, triggered by natural hazards as well as human action, resulted in destruction of infrastructure, impacts global security, and increases the number of displaced and vulnerable people at risk or in need of humanitarian assistance. Under these circumstances, the phases of disaster response and recovery take precedence in the disaster management cycle, with the vision to focus on saving lives and minimizing economic loss and facilitating food and medical supply. However, many times, logistical shortcomings coupled with inhospitable terrain and harsh weather conditions can present certain risks to rescue workers when they're responding to emergencies. During this time, critical rescue or evacuation operations, keeping in mind the safety of the rescue team, unmanned aerial vehicles, UAVs, and disaster robots can be employed to overcome shortcomings related to disrupted infrastructure and increased inaccessible locations. As was exemplified in today's presentations and discussions, humanitarian organizations are increasingly relying on drones and robots to optimize the model for the delivery of multiple packages of relief items, including food, vaccines, and other medical supplies to remote locations within disaster-prone areas. These mechanical saviors afford flexibility of deployment with high coverage in a timely manner to survey disaster locations, identify survivors, and ensure evacuation to save lives. This has also made them an invaluable asset for operations initiated by the World Food Programme, WFP, OCHA, and even UNHCR in both disasters as well as conflict zones. On the pre-standardization front, the ITU, together with WMO and UNEP, has created the focus group on artificial intelligence for disaster management, which has been working on leveraging AI for monitoring and predicting natural hazards and disasters. As a next step in this focus group, it would be interesting to look into the remaining two disaster phases and steer its focus also towards examining the application of AI and related technologies for disaster recovery and reconnaissance to reduce loss of life after a disaster has occurred. As this focus group is an open platform, I would like to take this opportunity to invite you all to follow its work and contribute to its activities, with the hope that today's discussion will pave the way for us to expand on the autonomous vehicle domain and envision its application beyond our daily lives on the roads. I would like to hand the floor back to Anna to officially close the session. Thank you all for joining us to this webinar, and thank you for your kind attention. Over to you.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the satisfaction survey, connect with interesting profiles, or speak one-on-one using the chat and video function. After the 30-minute networking session, we invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits and poster boards, and build your personalized AI for Good program. It was a pleasure learning with you today. See you at the next AI for Good.